Hi, today we shall discuss on types of DC motor. Under different types of DC motor, we have classification as DC shunt motor, DC series motor, and DC compound motor. All these three motors are self-excited. So we are discussing only self-excited DC motors in the concepts. So coming to the DC motor, if you look at the circuit, we have a DC motor here, and the name shunt refers when this field is connected in parallel with the armature of this machine. So when the field is connected in parallel with the armature of the machine, we denote that as DC shunt motor. So in DC shunt motor, when you look at this appears just like a simple DC circuit having the voltage which is common in all the parallel branch. So across this armature, the supply voltage is same, and across this shunt field winding, the supply voltage is same. So since assuming it as a DC parallel circuit, so the current across this shunt field winding is given by V by RSH, where RSH is the shunt field winding. Now, coming to the current flowing in the armature is given as Ia is equal to IL minus ISH. So, the IL is the incoming current as soon as the supply is given. So, where IL is equal to Ia plus ISH. Therefore, armature current is denoted as Ia is equal to IL minus ISH. Now, applying KVL to this loop, that is the armature and the shunt, and if you derive the equation applying just KVL as we apply to the normal DC circuit, we get EB is equal to V minus IA RA minus brushed contact drop. So these are the two brushes which are associated at the two sides of the armature terminal, where the brush contact drop denotes with respect to both the brushes. In the shunt motor, if you observe, RA will be very small than RSH, and flux produced by this field winding will be proportional to the current passing through it. Therefore, flux produced in this field winding is proportional to this current ISH, where phi is proportional to ISH. Therefore, as long as the supply voltage is constant, the flux produced here in the field winding is also constant, because the current produced is based on the supply voltage. So therefore, shunt motor is also uh, referred as constant flux machine, and this machine mainly used in medium torque requirement is there. Now coming to the DC series motor, when the field is connected in series with the armature, then it is termed as DC series motor. As I said, here the current, as soon as you give the supply, the current flowing will be same in the series as well as armature. Therefore, IL is equal to ISC is equal to IA. Now, applying KVL to this circuit, we get EB is equal to V minus IA into RA plus RAC, as these two are in series, minus brush contact drop. So here RSC is very small, like RA is very small compared to this RSH. Here RSC is very small, therefore entire armature current is passing through the series winding, so flux produced is proportional to the armature current, so flux is proportional to ISC and also proportional to IA. Now coming to DC compound motor, we have two types, that is cumulative long shunt and short shunt compound motor. If you observe, the difference between cumulative long and shunt compound motor is the long shunt refers when the field is connected to both series and armature resistance. That means the field is in parallel with the armature and the series field, then it is called as long shunt compound motor. When this series is, when this shunt field winding is connected just across the armature, excluding the series resistance, then it is called short shunt compound motor. Now, coming it to the cumulative part, cumulative refers when the flux produced in this field and this series are added up. So, therefore, it is called cumulative. In terms of, the flux, that is phi SC plus phi SH will be the total flux. In case of differential long shunt and short shunt, long shunt and short shunt refer to the same meaning, where we connect the shunt parallel to the series and armature. We call this long shunt compound motor. When this shunt is only parallel to the armature, we call that as a short shunt. Now, differential refers when there is a difference in the flux produced in the shunt and series field. That means phi sh minus phi sc will be the differential flux produced, or the total flux produced in the machine. Now, for that, we just have to interchange the terminals of the series field connected to the armature. So earlier, if you look at, the terminal was YY connected to the armature. In both the cases, long and short shunt of cumulative compound motor, in differential, the terminal of this is changed. That means if you have to produce a differential difference in the flux produced in the series and shunt winding, then we just have to reverse the terminals of this series field. Now, DC compound motor, as I said, equation for long shunt and short shunt. So, differential and cumulative is, just the difference in the flux, but the equation for long shunt and short shunt remains the same. So, as we refer, this is a long shunt cumulative and short shunt cumulative. Differential also holds good with the same equations, where ISH will be equal to V by RSH in case of long shunt, and IA will be equal to IL minus ISH. Therefore, if you apply a KVL to this circuit, it is EB is equal to V minus IA into RA plus RSC minus VB, as these RSC and RA are connected in series. Now, coming to the short shunt, if you observe the shunt current which is flowing here, which is just the current V minus the voltage minus IL, the drop across this, divided by this RSH. Therefore, IA will be the current, that is IL minus ISH. Now, EB, if you apply a KVL to this loop, EB is equal to V minus IL RSC minus IA into RA minus VB is equal to, that is EB. Therefore, the equation for shunt and long shunt has a difference. For short shunt, we don't include RSC with RA, but for long shunt, if you observe, since shunt is in parallel with this RSC and RA, the equation here differs. Thank you for watching this video.